Hey, what is up guys? Welcome to another video. In this video I'll be going through some difficult ratio questions. Now in my last video I did ask you to email me if you needed help on any particular questions, and by far the most common questions were ratio questions. So I had heaps of people emailing me different problems, and I tried to reply to all of them, but I didn't quite get to everybody. So sorry about that, but the most common questions were ratio questions, so I thought I'd do a video with all of the questions people sent me. And ratios is a topic that people commonly struggle with. I'm not sure why that is, but I think it might be because there's not always a clear method to how to approach ratio problems. I can't tell you the best method, because sometimes, depending on the type of question, the type of method that you can use to answer the question will change. So I think maybe that is why often it's hard both to learn about ratios and also to teach ratios, because if I'm telling you, it depends on the question, then I can't really recommend the best strategy to use. But in this video I'm going through 7 different problems, all quite difficult, so hopefully you can see a range of strategies to use to tackle these types of problems. So let's get into the questions. So the first one says, given that a to b equals 8 to 5 and b to c equals 3 to 4, find the ratio a to b to c, and give your answer in its simplest form. So this is a bit of a warm-up question. The other ones are going to be a bit more difficult than this one. If we have the ratio a to b, which is 8 to 5, and then b to c, which is 3 to 4, and we want to combine these ratios into a to b to c, we want these numbers here, this 5 and this 3, to be the same. So I need to multiply this 8 to 5 by something, and this 3 to 4 by something, so that this number here, this 5 and this 3, will be the same. So what you could look for is the lowest common multiple of 5 and 3. And in this case, it's just the same as multiplying 5 by 3. And that's another way to do it. You could just multiply 5 by the other number, which is 3, so they're the same. In this case, we get the lowest common multiple, which is 15. But that won't always be the case. Sometimes the lowest common multiple will be less than if you just multiply them together. But anyway, if we multiply this one by 3, we get 24 to 15. And if we multiply this one by 5, we get 15 to 20. Okay, so you can see here the number relating to b in the ratios is the same, 15 here and 15 here. That allows us to combine the ratios. So now I can say a to b to c will be 24 to 15 to 20. And then just check if that's in simplest form. So can you divide by anything? Can you divide by 2 or 3? Well, no, you can't. So this is in simplest form, 24 to 15 to 20. So that's one way to approach these types of questions, where they're asking you to combine 2 ratios together. Make sure the numbers relating to the middle number are the same. So you need to multiply each ratio by some number. The next question says, Anna and Bill share some money in the ratio 2 to 5. Anna gets A pounds, Bill gets B pounds. Carl and Donna share twice as much money as Anna and Bill share. They share the money in the ratio 3 to 1. Carl gets C pounds, Donna gets D pounds. Find the ratio A to B to C to D. Give your answer in its simplest form. Okay, one way to approach this is to say that Anna and Bill, the amount of money they have that they share, will be X. So Anna and Bill have X amount of money, and if they share that in the ratio 2 to 5, well, Anna, how much will Anna get? Well, they've split it up into 7 parts, and she's getting 2 of those parts, so she will get 2 out of 7 X pounds. Right, so this is the total. She's getting 2/7 of that total. So Bill, he's getting 5/7 of this share, so he's going to get 5 out of 7 pounds, 5 out of 7 X pounds. And then we could look at Carl and Donna, and we're told that they have twice as much money as Anna and Bill. So if we say Anna and Bill have X pounds, Carl and Donna will have 2 lots of X pounds. And how much will Carl get? He will get 3 out of 4, right? So this ratio is split into 4 parts. He's getting 3 of those parts, so he's getting 3/4 of the total. And remember the total here is 2x, not just x, but 2x. So he's getting 3/4 of the total, which is 3/4 of 2x. And then Donna is getting 1/4 of the total. And this could be rewritten as 2x times 3 on 4. That's just the same thing. And then you notice that this 2 here can cancel with a 2 on the bottom. So 4 divided by 2 is 2. So this can be rewritten as 3x on 4, or 3/4 x, whatever you like. And same for this one, you notice that this 2 can cancel with a 2 on the bottom. So Donna will effectively get 1/2 x pounds. Now we can compare the amounts that they get each. So we've kind of changed these ratios into amounts that we can compare between Anna and Bill and Carl and Donna, because they're all in terms of x. So we can write the ratio A standing for Anna, B standing for Bill, Carl and Donna. We can rewrite that as 2/7 x to 5/7 x to 3/4 x to 1/2 x. And because it's a ratio, we can effectively cancel the x's out, right? So remember, if you have a ratio like 2 to 4, common factor there is 2, so you can rewrite that as 1 to 2. It's still the same ratio, even though you've got rid of or divided by 2. It's still the same equivalent ratio, so here we can divide everything by x and we'll still have the same ratio. So we'll have 2/7 to 5/7 to 3/4 to, whoops, that shouldn't be a 4, should it? That should be a 2. Sorry, just going back a step, that should be 2 there. Sorry if that was annoying you. And 3/2 and 1/2. And then to get these as whole numbers, we can multiply everything by 7 and multiply everything by 2 to get rid of the fraction. So if you multiply everything by 7, we'll have 2 to 5 to 21 on 2 to 7 on 2. And then if we multiply everything by 2, we'll have 4 to 10 to 21 to 7. And so this is the final ratio of A to B to C to D in its simplest form. No fractions and no common factors. So 4 to 10 to 21, 7 there. Okay, the next question says, Mary mixes white paint and blue paint in the ratio 2 to 5. She makes a total of 21 litres of paint. How much more blue paint does she need to add to the mixture so that the ratio of white paint to blue paint becomes 1 to 4? Right, so if we have white to blue equals 2 to 5, and we have a total of 21 litres of paint. If we want this ratio to be 1 to 4, this is the same as 2 to 8. So how can I change this 2 to 5 into 2 to 8? Well, I need to add 3 parts blue paint, right? So I have the ratio 2 to 5 parts blue paint, and I need the ratio 2 to 8, which is the same as 1 to 4. So I need 8 parts blue paint. How do I get 8 parts blue paint? I need to add 3 parts blue paint. Okay, so let's firstly work out what one part of this ratio is equal to. So we have 7 parts, and that's 21 litres. So one part will be 21 divided by 7, which is 3 litres. And then 3 parts will be 9 litres. So we need to add 9 litres of blue paint. So we can say add 9 litres of blue paint, and that should answer the question. So how much more blue paint does she need? 9 litres. Okay. The next question says, Abby draws 2 triangles A and B. The height of triangle B is 1 centimetre more than the height of triangle A. The base of triangle A and the triangle B are the ratio 1 to 3. The areas of triangle A and triangle B are in the ratio 2 to 9. Triangle B has an area of 45 centimetres. What is the ratio of the vertical height of triangle A to the vertical height of triangle B? And you'll notice this says non-calculator, but this could come up in a calculator paper as well. So I think it's still, if you're revising for the calculator paper coming up, then I think this is still useful. So we have 2 triangles. The first thing I'd suggest is draw some diagrams. So draw out triangle B, and then triangle A was slightly smaller, 1 centimeter smaller. And we're told, the first bit of information we're told is B is 1 centimeter higher than the height of triangle A. So what I would do is to label this height some number or variable such as h, and then therefore the height of B will be h plus 1. Okay, the idea is to start to help you visualize this problem and help you with your problem solving process. Then we're told the base of triangle A to the base of triangle B is the ratio 1 to 3. So if we called the base B, then the base of triangle B must be 3B. So this is A and this is B. And we're also told the area of triangle A and triangle B are in the ratio 2 to 9. So the area of A to area of B equals 2 to 9. And we're also told the area of B is 45 centimeters. Okay, so we could say that area of A to 45 centimeters equals 2 to 9. And we can use this idea of equivalent ratios to find out the area of A. So what do I have to multiply 9 by to get to 45? That will be 5. So I need to multiply this ratio by 5 to make it equal to this ratio. So this is going to be the same as 10 to 45. So therefore I can say that the area of A equals 10 centimeters squared. So that line there, that bit of information allowed us to figure out the area of triangle A. Now we have the area of B and the area of A. We still have the height and the base that we don't know, but we have a way of creating some equations which will allow us to solve for H and solve for B. Okay, so the first equation we can say is that the height of A times the base divided by 2 is the area of the triangle. And we know the area is 10, so we can say that equals 10. So therefore, height times base equals 20, multiplied by 2 on the right hand side. And then the height will be 20 divided by B. Next, we can also say that the base of B, which is 3B, times the height, which is h plus 1, divided by 2 equals 45. And so then we can say 3b times h plus 1 equals 90 times by 2. And then we can substitute this value for h into this equation and we can solve for b. So we can find the base of A. So what I might do is expand these brackets out maybe first. So this will be 3bh plus 3b equals 90. And then substitute h in. So this will be 3b times 20 on b plus 3b equals 90. So then we have 60b on b plus 3b is 90. Now these b's over here, they will cancel out. And then we can subtract that 60 from the right hand side. So we'll have 3b equals 30. So b equals 10. Okay, so now I know the base of A is 10 centimeters. And I can figure out the height. So the height was 20 divided by B. So therefore the height will be 20 divided by 10, which is 2 centimeters. So I have the height of A. I can also work out the height of B. So we can say height of A was this h, 2 centimeters. So therefore the height of B will be 2 plus 1, which is 3 centimeters. And then go back to the question, what is the ratio of the vertical height of A to the vertical height of B? That will be, so height of A to the height of B will be 2 to 3. Alright, so that's the final answer there. I'm not sure if there's any shortcuts in this problem. I think this is a fairly long way. And also I'm not sure the number of marks of this question. I think it was a 4 or 5 mark question. But yeah, a fair bit of working out, but you get the idea. So you kind of set up 2 equations, solve for one variable, solve the other variable, and then you get the ratio. And we are actually going to use this strategy for the rest of the questions in this video. They're all kind of following along the same lines. So the next question says, at a school there are X Year 8 students and Y Year 9 pupils. If 10 pupils from each year group left the school, the ratio of pupils in year 8 to year 9 would be 2 to 5. If 8 pupils were added to each year group, the ratio would be 1 to 2. Express x as a percentage of y. Okay, so we have a variable x, so we can say year 8 equals x and year 9 equals y, and we're told if 10 pupils from each year group are left the school, the ratio would be 2 to 5. So we can say x minus 10, right, the number of pupils in year 8 minus 10 who left, to the ratio of year 9 pupils minus 10 will equal 2 to 5. So this is the first ratio. We're also told that if 8 pupils were added to each year group, the ratio would be 1 to 2. So the second ratio will be x plus 8 to y plus 8 will be 1 to 2. Then we can rewrite these ratios as fractions. So the first one will become x minus 10 over y minus 10 equals 2 over 5. And we can rearrange this so that we have it in the form of an equation with x and y without the fractions. So we can cross multiply. So multiply y minus 10 on this side and 5 on this side. So we get 5 times x minus 10 and 2 times y minus 10. And then expand the brackets out, so we get 5x minus 50 equals 2y minus 20. And then we can subtract the 2y from the left-hand side. So we get 5x minus 2y equals, and then add the 50 to the right-hand side. So minus 20 plus 50, that would be 30. So you can see from this ratio, we can create an equation without any fractions, and it's kind of, x and y on the left-hand side. Then we can do the same for the second ratio. So we can turn that into a fraction. So x plus 8 over y plus 8 equals 1 on 2. And then cross multiply just as we did before. So 2 times x plus 8, that would be 2x plus 16 equals y plus 8, and then simplify further, so subtract the y from the left hand side, so we get 2x minus y equals, and plus 8 minus 16 is minus 8. And this might look very similar to simultaneous equations like you've done before. So we have one equation looking like this, 5x minus 2y equals 30, and one equation looking like this, 2x minus y equals minus 8. And so if we take those two equations, we can solve them just as we would with regular simultaneous equations. Okay, so the first one is 5x minus 2y equals 30, and then I might use the elimination method. So if I times this equation by 2, I get 4x minus 2y equals minus 16, and then I have this minus 2y and this minus 2y equal. So if I subtract those two equations, then I'll be able to eliminate the y and find what x will equal. So if I subtract this equation from the first equation, 4x minus 2y equals minus 16, 5x minus 4x, that's x, minus 2y minus 2y, that's minus 2y plus 2y, is 0, so they eliminate each other. Then we have 30 plus 16. So minus and a minus make a plus, so this will be 46. So x equals 46. And then stick that into another equation, such as this one. So if I take 2x minus y equals minus 8 and substitute 46 into that, I will get 2 times 46 minus y equals minus 8. So 2 times 46, that's 92, minus y equals minus 8. And then minus y equals minus 8 minus 92, so that will be minus 100. So therefore y equals 100. And let's go back to the question again. I have x equal 46 and y equals 100. Remember that the year 8 students was x and the year 9 students was y. So therefore I can say there were 46 year 8 students, 100 year 9 students. And so x as a percentage of y, that will be 46%. And you could put those numbers back into one of these original equations. So put 46 in here and 100 in there and see if it equals 2 and 5. So that's one way to check your answer is correct. But x is 46% of y is my final answer for that question. Next question says, a bag contains sweets that are either red, yellow or green. The bag contains equal numbers of red and green sweets. Luke eats 5 red, 15 yellow, and 25 green sweets from the bag. The ratio of red to yellow sweets remaining in the bag is 2 to 3. The ratio of yellow to green sweets remaining in the bag is 3 to 1. What fraction of the sweets originally in the bag were yellow? Give your answer in its simplest form. Okay, so difficult to know where to start with this question because there's lots and lots of information here. But I started off by giving variables to the red, yellow, and green sweets originally in the bag. So I said that red sweets was X, and we're told that red and green sweets had equal numbers, so that means the green sweets were also X, and the yellow sweets I called Y. So they're X red sweets, X green sweets, and Y yellow sweets. And then we're told that he eats 5 red sweets, so we could represent that as X minus 5. So this is originally, and then this is after Luke eats some sweets. And then we're told that he eats 25 green sweets, so we have X minus 25 green sweets. And then we're told he eats 15 yellow sweets, so that is Y minus 15. Okay, so we originally had X, and then we had X minus 5 red sweets, etc. And then we're told the ratios of red to yellow sweets is 2 to 3. So red to yellow is 2 to 3. And we're also told that the ratio of yellow to green sweets is 3 to 1. So the new ratio is yellow to green equals 3 to 1. If we want to write this as a ratio of red to yellow to green, we could, because you notice that the number for yellow sweets in both ratios is the same. So I can easily write this as red to yellow to green as 2 to 3 to 1. What this tells me is that the ratio of red to green must be 2 to 1. So then if I rewrite that as a fraction, red over green equals 2 over 1, or just 2. So then for every red sweet, I have 2 green sweets. Okay, so now I can use that equation to say that, remember the equation I had for red was X minus 5. So I can say X minus 5 equals 2 lots of the green sweets, which was X minus 25. Then I can expand this out and solve it for X. So I'll have X minus 5 equals 2X minus 50, and then subtract X from this side, so I have X, and add 50 to this side, so I have 45. So X equals 45, so originally I had 45 red sweets and 45 green sweets. I still need to find how many yellow sweets I had, and I could do that by using one of these ratios. So I know that the ratio of red to yellow was 2 to 3. And so if I had originally I had 45 red sweets, I now have 40 red sweets. So 40 to Y minus 15 equals 2 to 3. And then I can solve this for Y. So 40 over Y minus 15 equals 2 over 3. 3 times 40 is 120. 2 times Y minus 15 is 2Y minus 30. And then I have 2Y equals 150. So Y equals 75. So now I can find the original amount of sweets. So I had 45 red and green sweets and 75 yellow sweets. I can add those up. So 45 red sweets plus 45 green sweets plus 75 yellow sweets. That adds up to 165. And remember the question was saying what fraction of the sweets originally in the bag were yellow. So 75 yellow sweets originally and 165 sweets in total. So the fraction of yellow sweets equals 75 on 165. And that simplifies to 15 on 33. So that's my final answer for that question. I think that was maybe a 4-mark question. And this is the last question I'm going to go through. Pause the video if you want to have a go. I'll give you a clue. I'm going to use a similar method as I've done for the last 2 questions to solve this one. So if you do want to have a go using my method, pause the video now. So the question says, Island X is a small island. In the winter of 1986, the ratio of natives to tourists in the island was 7 to 1. In the summer of 1987, the ratio of natives to tourists on the island was 155 to 69. The number of natives on the island decreased by 100 from the winter to the summer. The number of tourists on the island increased by 220 from the winter to the summer. So find the number of tourists that were on the island X in the winter of 1986, so originally. So firstly, let's give some variables to these amounts. So we could say the natives will equal X and the tourists will equal Y. And so let's write the ratios. So the number of natives to tourists was 7 to 1 originally. So in 1986, we had X to Y equals 7 to 1. And then in 1987, we're told the number of natives on the island decreased by 100. So that would be the original amount minus 100. And the number of tourists increased by 220. So that would be the original amount, Y plus 220. And that ratio was 155 to 69. Okay, so now again you can see we have these two ratios with two variables. We can change them into two equations and solve for X and Y. Okay, so let's take the first ratio. We've got X to Y equals 7 over 1, which is just 7 basically. So then we can say that X equals 7Y. The second ratio, we can say that X minus 100 over Y plus 220 equals 155 on 69. And then cross multiply as we have been doing. So 69 times X minus 100 equals 155 times Y plus 220. And then 69X minus 6,900 equals 155Y plus 155 times 220. Not sure if this is a calculator or non-calculator, but let's just assume it's a calculator question. If you put 155 times 220 into your calculator, you get 34,100. And then let's simplify this a little bit. So we get 69X minus 155Y equals 34,100 plus 6,900. That's 41,000. And then remember that X equals 7Y, so we can substitute that into this equation. So 69 times 7Y minus 155Y equals 41,000. And then 69 times 7, that's 483Y minus 155Y equals 41,000. 483 minus 155, that's 328Y equals 41,000. So Y will equal 41,000 divided by 328, which is 125. Okay, so remember that Y was the number of tourists originally on the island, and the question is saying find the number of tourists that were located on island X in the winter of 1986, which was this original amount Y, so we can say that the number of tourists in 1986 equaled 125. And you could check that amount if you substitute it into the equations. You could find X and then substitute them in to check you're correct. But that's my final answer for that question. That's the last question I'm going through. Let me know how paper 2 went today. I'm really curious to hear how you felt about it. Were there any questions that you struggled on? Were there any kind of surprising questions? So let me know in the comments. Leave a like if you appreciated this video. Subscribe if you want to see more content, and I'll see you in the next one. Bye for now.